Welcome back, ladies and gentlemen, boys and girls. Welcome to another exciting episode. And today, I'm going to break down one of the most powerful but underrated optimization that you can use right now. So today we are going to talk about TOON, that is token-oriented object notation. So TOON is a compact data format designed to specially cut down your token usage when you talk to a OpenAI API kind of thing, or for that matter, any LLM that you are talking to via APIs. In this video, we are not just going to talk theory, but also we'll do a head-to-head comparison between JSON and TOON, how many tokens each one uses, and how much it really costs you when you use JSON versus when you use TOON, and why you might be wasting money even without you realizing it. So if you're a developer, a tech enthusiast, or anyone building anything with AI, then this is the video for you, because by the end of this video, you will know how to save tokens, how to save your money, and build really fast with AI. So stick around because the results might surprise you. All right, so with this said, with this context set, let's get started with the video. All right, so this is the official documentation of TOON. And if you look at this place over here, it says token-oriented object notation over here. Compact, human-readable, schema-aware JSON for LLM prompts. Spec, benchmarks, and TypeScript SDK. So it gives us this package gives us an SDK for TypeScript. But down below, there is a very interesting diagram that they have done. So this diagram over here, it says that you give it a JSON, then you use this encode function from this TOON library, and after you convert the JSON to TOON, and then you send it to LLM. Now, when you convert this to TOON, the tokens that you are creating will be actually 30 to 60% less, and that is a huge difference, I believe. Further, if you come down, it says that TOON is a compact human readable encoding of the JSON data model for LLM prompts. Okay. It says TOON combines YAML's indentation based structure for nested objects with a CSV style tabular layout for uniform arrays. It has TOON's sweet spot is uniform array of objects. Okay. Multiple fields per row, same structure across items, achieving CSV-like compactness while adding explicit structure that helps LLMs parse and validate data reliably. Now you can take your time, go through this link. I'll put this link in the description and read about it. I've already done it. I'm not going to do all of it all again, but I'm going to tell you the gist of it. Now, so this TOON library is going to work best when it has got a flat JSON structure. What do I mean by saying flat? Okay. Now, below there is this JSON structure. If you look over here, it says users, and then there are a couple of users over here. Now, if you look closely, there is no nested object inside a JSON object. We could have another field called address, and then inside that we could have another objects like, what is the street number, the address, the pin code, and other stuff. So we don't really have any nested structure into it. And this is the speciality of TOON, that it works best when your JSON is a flat JSON. It is not a nested JSON. So we'll look at an alternative later, but for now, let's understand that TOON works best when you have got a flat JSON. Furthermore, so this is your JSON, this is the YAML, and then this is the TOON. Okay, so if you visually compare all these three things, you will see that number of tokens inside the TOON is far less than when you add a JSON. So in a JSON, even this is a token. This inverted commas, double inverted commas is a token. This square bracket is a token. This comma over here is a token again. But inside of TOON, you hardly see any braces. You hardly see any, double quotes anywhere. It's just colon and, this comma. Yeah, couple of brackets, but yes, they are far less than what we had in TOON. Okay, one more quick thing. So if you look at this description, you go through it, it says it is inspired from YAML and CSV. So now if you look at this place over here, you see this is my JSON, this is YAML, and if you see the indentation kind of thing, and if you look at TOON now, the indentation is quite similar to what we used to have in YAML. So it is kind of inspired with YAML, and this is how it is able to save a few tokens for us. And then it also says that it is inspired from CSV. So if you look on the CSV, in a usual CSV, we have this kind of, the column names are written once, and then, under that we have got all other values. So it is kind of inspired from CSV and YAML, and this is how it saves us a few tokens. Cool. So I would suggest you read through all of it. There are also a few benchmarks that they have given that, if you were using TOON, how much were you able to save, and for JSON, for YAML, and all those kind of things. Also, they have compared this with several different LLM models. So across 4 LLMs on 209 data retrieval questions, this is the kind of metrics that they are proposing, that they claim that TOON is able to achieve. So just have a look at that. This is really very interesting, and it is the most underrated piece of tech that we have at this moment. So if you are able to, get a hold of it, propose it at your workplace in your solutions, and maybe you could build something good. Cool. Now, with this said, with all this, reading material we have gone through, let's actually start doing some code, and let's actually see this tool in action. All right, so now we are on VS Code, and I've got a pretty little code ready, and we'll look through what this code is doing, and we'll try to understand how Toon helps us in reducing the amount of tokens that we send to LLM. So my first code is JSON query. Over here, first of all, I have got this data employees.json, which has got 10 objects into it. Pretty simple, nothing fancy over here. A plain, simple, flat JSON object, which has got ID, name, and some department and some platform, or some department and some salary details of every employee of 10 employees. Cool. Now I've got this another file called JSON query.js. Now what this does is it imports a few things. It says, okay, give me file stream. Okay, and then give me OpenAI from OpenAI module, and then it is using this tokenize module from GPT tokenizer. So we'll look what this does for us. Now I've brought in my API key from OpenAI, and I've made a client out of it. All right, so now this is my input rate per minute per million token, and this is my output rate per million token. So if you look at the OpenAI pricing models, you will see that for every 1 million input token that you send to LLM, it is going to charge you 15 cents. And for every 1 million token that LLM is replying to you, it is going to charge you 60 cents. Now, these numbers might not seem too high, but let's say you have built a solution that uses an OpenAI key, then and you are receiving several and tons of hits to your API, then these numbers matter. But overall, our goal is to reduce the number of tokens. And also we look at the impact on the cost. Okay, then I'm going to load the data from my employees.json file, and I'm going to stringify. And then this is my tokenized call, which is going to figure out how many local tokens I'm sending it from, as a part of my payload. So this employees.json is my payload, is my data set, and how many tokens I'm using, how many tokens are there in this employees.json. All right, then, okay, this is some error handling. Let's forget that. And then there is a prompt. I'm going to say that you are an HR analytics assistant and you have got this data from my employees.json, and these are the two set of questions that I'm going to ask to it. Then it is going to hit that, and it is going to hit the OpenAI, and it is going to get me some results. So here is my message content, and these things over here are going to tell me how much it costed me or how much was the tokens usage. So first up is the input tokens, how much input that we gave it and how much was the tokens into it. What was the reply and how much output token did it take? Now the total tokens and the input cost, output cost, and the total cost. So this in all will give us a clear picture of how much token it used and how much did it cost us. So very quickly we'll run this and see. I'm going to open my terminal over here, and I'm going to say node JSON underscore query dot JS, and let's look at the results. So it is running, and it is taking a little while. I got this code all from Copilot. I just wish it doesn't fail. Oh no, it did not. All right, so here are my metrics. So here So these are the results. Let's not look at that. What matters to us is the token and the cost. So it says that the input tokens were 453, output was this, and it costed me around 68.00068 cents or whatever the unit may be, for the input. And this was my output, and it totally costed me this much. So I'm going to copy this and I'm going to paste it somewhere, maybe some another file over here. Let's create one more file. Come on. Okay, new file, and this is what we get. Okay, cool. So this is what we get. Now let us look at the other file. Now let's look at this TOON underscore query.js file. Now what this does, it has got one more thing, that is the TOON format, the TOON library or the package that we were looking at. And everything else is same. There's just one small difference. Instead of doing JSON.stringify, I'm saying TOON encode. Correct? So I'm not doing that JSON.stringify, I'm encoding it with the TOON library over here. Everything else is the same. You can compare it. I'll put a link to my GitHub repo for this repository and you can have a look. All right, so now let's run this TOON query. Okay, so let me shift my recorder, and instead of JSON.query, I'm going to say TOON underscore query.js. Let's look at the results. All right, so now this is what I get. Let me copy this and let me bring it over here. Command V, and let me comment it. Cool. So now let's compare the results. This is my JSON. The OpenAI input tokens costed me 453 tokens when it was JSON, but when it is TOON, it is just 208 tokens, like just half, even more than half. So this is way better. So the output tokens, let's not look at that. So now let's look at the input cost. Now input cost for TOON was just 0.00031, and over here it was 0.00068. So even that is half. So I think that pretty much summarizes that using TOONs for sending inputs to LLM is way better, way cheaper, and then way economical than using JSON for sending inputs to LLM. All right, so this was it for this video. I believe it helped you to figure out what is the need of the state, what is the need right now, whether to use JSON, whether to use TOON. And if it did help you in building something better, I request you to please subscribe to my channel, like this video, and share it with your friends and family. All right, so with this said, let's conclude this video over here, and I'll see you in the next one. But until then, goodbye.